Hello students, in today's video lecture of machine drawing, I'll continue with riveted joints, which we already had a discussion on. Riveted joints, where we already discussed all the concepts and the formulas to remember and how to draw the representations. I have explained you the concept completely. Now in this lecture, we'll see how to put them all on a piece of paper. Like for example, a question is given to you in the examination, how to represent that on your drawing sheet, the front view, top view of that particular question with respect to the dimensions. Okay, now let us take this video lecture as Rivet 2. Okay, directly I'll explain you the actual drawings when you get a in your examination. Fine. Now I'll straight away start off with, let us take first question as single riveted lap joint. We'll try to differentiate lap and butt. Okay, initially we'll discuss about lap joint. As we already had a discussion, like lap means sheet placed one over the other, and from the extreme end point we'll try to place an axis line where we'll try to drill the hole of whatever the diameter given in the question. Okay, and here this extreme end makes an inclination of 80 degrees with respect to horizontal, similarly to other side also. And we are not bothered about this end as well as this end of sheet number 1 and 2. If you take this as 1, this as 2, we don't bother about this because we can go up to any extension, infinite distance. It all depends on the wish of the student. Okay, similarly we'll go with a drilled hole, then we'll try to place the rivet. This we had a discussion already. Now I'll go into actual drawings or actual sketches when a question is given in the examination. Let us take first question. Let us imagine that the question is about a lap joint. It is single riveted lap joint. I'll write it in a short form, single riveted lap joint. You can call it a single riveted chain lap joint also. Okay, chain lap joint also. If something is not represented, chain or zigzag not represented, means you can go with chain only all the time. Okay, now if it is a lap joint, no need to think about T1 and T2. There will be only T. Okay, unless it is a butt, no need to think about T1 value and T2 value. Okay, now single riveted lap joint. The question may be something like this: draw the representation of single riveted lap joint by taking T is equal to, for example, T is equal to 4. This might be your question. So if this is your question, what you need to calculate, D is equal to 6 root T. D is equal to 6 root 4. That is equal to 6 into 2, that is equal to 12 mm is D. If D is 12 mm, what is P? P is equal to 3D, that is equal to 3 into 12, okay, that is equal to 36. Fine, this is 36 mm. P is nothing but the pitch, okay, the value which you need to use in between two rivets, okay. And one more value we need to see, 1.5D need to be considered from extreme end of that particular sheet. For example, from here to this point it is going to be 1.5. Try to remember. Okay, now as I know T value, T is equal to 12 mm, I'll consider 12 thickness sheet initially. Okay, for example, I'll start somewhere here. This end I'm not bothered about, so I'll try to draw a zigzag line followed by a straight line. Then again from here I'll measure 12 mm, I'll draw one more line up to some infinite distance, close. Okay, some infinite distance I have taken, I am not measuring the length. So okay, from this point, end point, from the extreme end you need to calculate 1.5D. so from here I need to calculate 1.5D, draw a dimension line, okay, then place an axis line. Okay, now again from this point it is maintaining 1.5D. okay, drop this line onto the sheet number 1. Means here your next sheet should start at this particular line, because this is also maintaining 1.5D, this is also maintaining 1.5D. okay, so again 12 thickness, from here drop down. This time I'll use some other color to make you understand better. Sheet number 1 with blue color, maybe sheet number 2 with a green color. I'll try to take an extension beyond this. I'll close it with a zigzag line. This is also maintaining 12 mm. okay, now both are maintaining 12 mm distance, I mean thickness. Okay, now here I need to drill a hole from top to bottom. What is the diameter? 12 mm diameter again. Okay, from here 12. Fine. Now I made a mistake, small mistake is there, forgotten to take 4. Imagine that this width is 4 and not 12. 12 is your diameter, what you calculated. D is 12. Thickness is 4. Okay, this is also 4. 4 mm thicknesses, 12 mm diameter. Okay, 4 mm thickness, 12 mm diameter. Now I'll try to place rivet is of this shape. We already seen the before lecture with some taper session, with some 0.7D as height of head and 1.6D as the diameter of the head. I'll consider these two. How to place? I'll take 1.7D from here. I'll make a mark of 0.7D on the axis line. Then what I do, we are supposed to consider again 1.6D by 2 will give you the radius. So from this point calculate take a value of 1.6D by 2, which will obviously cut the axis somewhere here, which is above, beyond the intersection. Okay, taking this as the center with your compass, whole thing as radius again in a reverse way. From here to here as radius, draw a curve until it meet with the horizontal of sheet number 1. This is how you need to draw, and close this line also. Similarly, same thing, same attempt need to be done here also. You will get a rivet head, something like this. Okay, close this line, and whichever got inserted inside, that is invisible, draw a dashed line. Okay, now here it is 1.5, it is maintaining 0.7D is 1.6D, same thing need to be followed. Now how to draw the top view of that particular component? I'll take the projectile lines from here, projectile line of sheet number 1, this is one more. Okay, now here you need to remember one thing, that we need to maintain an angle of 80 degrees with respect to horizontal when it comes to the extreme end point. So from here the sheet need to be cutted or chamfered, something like this. Okay, this portion need to be removed. So this angle is 80 degrees, this angle 80 degrees with respect to horizontal. Same thing need to be done this side also. Okay, with respect to horizontal, not vertical. Remember, when you make it to 80 degrees, here you will get two end points. Initially you have only one end point, now you have two end points because it is making some inclination. Take that projectile line also onto the top view. Okay, onto the top view roughly. Fine. Now draw a sheet number 1. Try to draw sheet number 1. It is starting somewhere here. I'll try to draw sheet number 1 with a zigzag line. It is ending somewhere here. Again a zigzag line at this end also. Here you can end up. Okay, now this zigzag indicates that sheet length is very much big. We are cut shorting it just to represent the rivet. Okay, so this distance is conventional, this width is also conventional. Whatever the width you have considered in front view, same need to be considered in the top view also. Okay, if this is the representation of your what you call sheet number 1. Similarly sheet number 2. I'll start with sheet number 2 now. For your understanding, I'll change the color. It is starting somewhere here. Whichever the line which is coming inside, I'll try to make it invisible. Okay, again invisible, again darken it. From here darken it, make a zigzag, darken it. Draw one or two zigzags are enough. Okay, it is not compulsory that you need to place 1 or you need to place 2. It all depends. Okay, one more hidden line need to be placed. This is the representation when I view from the top, front view, top view. When I view from the top, I could see 1.6D diameter, and also this D is invisible. Okay, D is invisible. I'll try to take the axis line, continue the axis line with a projectile line. Okay, now at a distance of 1.5D from the extreme end, 1.5D from the extreme end, for example from here, at a distance of 1.5, I'll try to draw D, which is 12, and again a continuous line which is 1.6D. Okay, again from here again there will be a D, there will be 1.6D. Only 2 rivet positions are enough to show on your drawing sheet. Okay, if you want you can go with 3 rivets also, but it will take more space. For representation 2 rivets are enough. And in between 2 rivets, what is the distance that you need to place? In between 2 rivets, what is the distance we are maintaining? That is P, which is 36. So from here to here, draw a dimension line specifying P, that is equal to 36. 3D, that is equal to 36. No need to draw all these things. When you draw in your calculation, only specify P, that is enough. Okay, front view, top view, this is how we will represent. Okay, what is that? Single riveted lap joint. Now straight away I'll go a bit faster now this time. What I try to do is, if the question is, I'll change the question now. This is the solution for this particular question. If the question is, for example, double riveted chain lap joint is your question. What are the changes you find in this particular? Simple, everything will remain same other than this, only other than one row you find two rows. That is the only difference. For example, beside this there will be one more rivet placed at a distance of 1.5d. Okay, one more rivet is placed at a distance of 1.5d from the first rivet. Okay, that is the only difference between these two. Fine. So that we'll see now. I'll make quickly I'll make a note. This is your sheet number 1. Maintain 80 degrees with respect to horizontal. Sheet number 2. I'll take same specifications. 4 mm. This is maintaining 80 degrees. Here it is also maintaining 80 degrees. Okay. Quickly I place rivet over it. Okay. This time I'll try to place the rivet a bit smaller to use the space properly. There might be there are two axis lines. From here to here, this distance is going to be 1.5d. Similarly, this case also it is 1.5d. Okay, in between two, there is a distance which is PR, that is equal to PR for chain. We have discussed already in the last lecture. For chain, PR is 0.8. P value we already know, so accordingly calculate P value. We'll get it. Okay. Now what I do is straight away I'll try to place riveted head, okay, followed by diameter, then one more riveted head. Similarly, one more head at a distance of PR. This is the arrangement. Could see. Okay, if this is the case, then we'll get assume or imagine that this is your sheet number 1. We'll get double line because it is making an inclination of 80. Similarly, in this case also we'll get double line because it is also maintaining inclination of 80 degrees. We will continue the line. This place again I'll take one more zigzag. I'll continue. I'll collide with this. Okay. Now here I'm mismatching both the sheets. If you want, you can match both the sheets. Not a problem. You can match this line with this line also. That is also not a problem. So this time what I try to do, I'll try to place, take an axis line, one more axis line. In between distance is 0. This is 1.5 distance. There will be a D followed by 1.6D. Okay, D followed by 1.6D. Again there will be a D followed by 1.6D. Visible and invisible lines I am drawing. Now here the distance between both the rivets is P, that is equal to 3D, which is 36. Similarly, the distance between two rows is PR, which is 0.8 P. If you calculate this, you can calculate this also. This is how you will get the representation. Okay. Suppose the question is a zigzag. If the question is a zigzag one, everything will remain same. Everything, almost all the things will remain same. Other than this, if you have two rivets at a distance of P, there will be on the other row, there will be one more rivet at a distance of P by 2, somewhere here. P by 2, one more rivet will be there. That is the reason zigzag will come this way. D 1.6D at a distance of, there is one more D 1.6D at a distance of P by 2, there will be one more D, one more 1.6D. Okay, this distance is P, and row to row distance if you take, this distance is PR, which is equal to 0.6P, 0.8P for chain, 0.6P for zigzag. Okay, if you could understand the difference between zigzag and chain, everything becomes so simple. Okay, so the question may be of this kind: single riveted, double riveted, chain type joints. Okay, imagine same question again. Fine, there may be same question again in case of a butt joint. We'll see a butt joint now. Number 3 question. If you take a butt joint, whenever you take a butt joint, the joint is going to be something like this. Okay, butted. You can't drill a hole here, or you can't drill a hole. Okay, it will become wasteful computation because drilling a hole on one sheet won't be effective. So you need to use a strap. The same discussion we had already in first lecture of riveted joints. We need to consider a strap of some thickness. What is the thickness? We'll see. Some thickness over, and we need to drill a hole now. So this strap acts as a supporting member for the butt joint. It all depends on the application point, whether you consider one strap or double strap. It all depends. And one more thing, if you use double strap, both the straps value going to be T2. Okay, this is going to be T, this thickness is T, these two values going to be T2. If you consider only one strap, then you need to consider T1 for one strap. Okay, If it is T2, straps should be 2. That is more important. Now we'll consider again same calculations. D will be given or T will be given. Accordingly calculate the other value with these formulas. Okay. Then again start with your question. I'll take 4mm again for this question. I'll draw a 4mm thickness butt joint. Here this length may be bigger, this may be shorter, it all depends. Okay. If you take equidistance, it is okay. If not also, no problem. Okay. But the thing is, strap distance is more important in case of butt joint, not the actual sheet distance, because here you can go up to infinite distance. You can go up to infinite distance. This side also, not a problem. But where you are going to start your strap is more important. The distance from the center of rivet to the end of strap is more important. Okay. If this is the joint, I'll take strap, I'll draw a strap with another color, maybe this one. I'll draw the strap something like this. I'm placing only single strap. The question is something like this. Draw the representation of a butt joint, single strap butt joint by taking, consider a single strap. Okay. By taking T is equal to some 6 mm, some 8 mm or 12 mm. Accordingly calculate D. Here I'm considering this 4. I'll go with 4 only. Okay. So it is single riveted butt joint. Okay. Single strap you can call butt joint. Single riveted, single strap butt joint. Now everything will remain same now. Okay. From the center of butt, wherever you made a butt, from the center to the center of the rivet, this distance is 1.5 D. This distance will also remain same, 1.5 D. Okay. Here you need to place your axis line. Okay. Now all other process is similar. All other process is similar. The way we did for lap joint. What we do, we will drill a hole of whatever the diameter we calculated. Then we'll place a head of dimension 0.7 by 1.60. 0.7 D by 1.60. I'll try to darken the required portion. This is similar. Only thing is we are changing the joint type. Other things will remain same. This is how we'll do. This is the front view. If you consider top view again, again draw the projectile lines 1, 2, 3, center line, extreme end point, strap, sheet, the other end of the strap, all these things. You need to project many things, and the butt, wherever both the sheets got joined with each other. Okay. After considering this, what you try to do is consider for sheet number 1, which is this blue one. Okay. So I'll make it zigzag. I'll continue till that point. Again I'll make it zigzag. You can place 2 or more, your wish. Close the sheet. Okay. Make one more zigzag here, because this side 1, 2, 3 sides we are taking an infinite distance. It is not specified actually. Okay. Second sheet I'll consider 1, 2, okay, 3. You can mismatch or you can match it, not a problem. You can take a mismatch also. No need to align this line with this particular line. If you want, you can mismatch this line also. That is also correct. No problem. Because we are not bothered about other 3 sides. We are bothered about one side where it got butted, and we bothered about the rivet's position. Okay, clear. Now wherever these 2 got butted, there is a strap on the top. So the butt is invisible now. Completely butt becomes invisible. So what you need to draw an invisible line. Okay, and there will be a strap on the top. So I'll try to consider strap. You can start here outside the sheet number 1 and 2, or else inside the sheet number 1. Okay, wherever you draw, no problem. You can start here also. I'll consider this point. I'll draw a line up to strap distance only, not beyond that, because these 2 lines indicates the extreme end point of the strap. Okay, then I'll continue this line also. Similarly, the other side also I'll try to continue. Okay, join with this. So this green one is your strap, which is aligning both what you call sheet number 1 and sheet number 2. Okay, after this again in a similar fashion try to place rivets D 1.6D. Okay, on this axis there will be D position 1.6D also. There will be D, there will be 1.6D. Similarly there will be D 1.6D. This is the case when it is a chain type. Okay. Now here when you draw a strap, one more thing need to be remembered. When you draw a strap, what is the thickness of the strap that you considered? That is more important. For this cover plate, what we are using, you can consider this green one as cover plate. 1.125 T. Substitute the value of T, which is 4. 1.125 into 4, you'll get the value. That is your T1. This is equal to T. 4 is your T. T is equal to 4, and this is your T1, whatever the value you'll get. Okay. If you take one more strap below, then you need to consider T2 also. Above and below T2, there won't be any T1. T2 is equal to, again there is a formula for that, 7.5 T. We have discussed earlier in the lecture of rivets. Okay, first lecture of rivets. Now this is a representation. Everything remains same. What is that? In between two rivets, what is the distance that we need to follow? From this point to this point, this will remain same as P. What is P? P is equal to 3D, that is equal to 36. It all depends on the value given, T value or D value given. Okay, and from this point to the center, from this center, both are maintaining 1.5D. Okay, everything is justified, front and top views. Okay, now what is the name given? Single riveted single strap butt joint, single riveted lap joint. So what is the condition I said? When it is a single riveted, there should be only single row. Okay, that row may contain 100 rivets or 1000 rivets, but single row is important. Okay, whereas in this case also we are calling it as single riveted single strap butt joint. We have two rows. Here the student will get confused. Here we are having two rows, we are calling it as single. Here we are considering one row, again we are calling it as. So what is the difference between lap and butt is, in this case if it is a single riveted single strap means towards one side of the butt joint, how many rows do you have? Towards one side I have only one row, then we can call it as single riveted. Okay, one side of the butt I have only one row, other side also one row only, so we can call it as single riveted. Okay, if you have one more row added, I'll make a rough sketch now. I'll make some rough sketch. For example, beside this there is one more rivet added. For example, I'll make a rough sketch. One more rivet added, something like this, at a distance of, okay, then what happens? There will be one more rivet added on the bottom, which is top view. One more rivet. You need to enlarge the size of your sheets as well as size of the strap also. Okay, you have two rows one side of your butt, so you can call this as double riveted single strap butt joint. Okay, when you can call this as double riveted double strap butt joint, when you have one more strap below somewhere here. Okay, the arrangement is something like this. There will be a sheet number 1, sheet number 2, and we'll consider strap above, one strap below. Now you can maintain an angle of 10 degrees here, not a problem. Okay, when there are two straps, this is T2, this is also T2, this is T. Okay, and from the center you need to place a rivet, something like this. Okay, this is the arrangement you are going to do. Fine. Now we'll see one more problem or one more drawing, which is about zigzag. We haven't discussed much about zigzag yet, so number 4 is about zigzag joint. Okay, what we'll see is double riveted lap joint. We'll try to solve a problem now on double riveted. Okay, maybe double riveted zigzag lap joint. Okay, double riveted zigzag lap joint. We know what is lap joint, we know what is zigzag, what is double riveted. Okay, everything is simple. Now he'll give you value of T is equal to some 4m. If T is 4, D is 12, P is 36, 1.5D from the extreme end point. Okay, I'll go a bit faster, have a look. What we try to do is, I'll consider T, this is T of sheet number 1 at 1.5D distance, one more T, I'll try to place one more. Okay, at a distance of 1.5D, I'll try to place an axis line. Okay, now again you are familiar with, here I'm going to maintain an angle of 80 degrees with respect to horizontal, 80 with respect to horizontal. Okay, again I'll try to place the rivet from the top and I'll do hydraulic or pneumatic press, so that I'll get a arrangement of this kind. Okay, here it is only double riveted single zigzag, double riveted zigzag lap joint, so you will get double. Fine, again I'll take all the projections below roughly from here. This is sheet number 1. Okay, here you will get double line, from here again you will get double line. Okay, close it somewhere away. Sheet number 2, again you will get double line. This time I am aligning both the sheets. Okay, now again draw the rivets position. If this is your axis line, D 1.6D, at a distance of P, D 1.6D. Okay, and one more row. This row will be added again. So at a distance of P by 2, there will be D 1.6D. Specifying those dimensions is more important. Fine. Now here, from here to this point, it is going to be P. What is P? P is equal to 36. And again, from here to this point, it is going to be P by 2. Okay. Now, in between these two rows, it is PR. In between two rows, it is PR. What is PR for zigzag? It is 0.6P. This is how you will get the arrangement. Fine. So this is how we will try to draw the representation of all the drawings. Only thing is we need to remember how the position or how the whether you are dealing with snap head or what. Here the whatever the dimensions or specifications I have used, this is about snap headed one. Okay. Now quickly we'll look at the hatching part. Okay, quickly we'll have a look at the hatching part. For example, we'll do hatching on the front view and on the top view some cases. What does it? It represents the cut section. For example, there is a cut section at this point from here. This is a cut section. This is how we'll represent a cut section. Okay, the name of, you can give PP as the name, or XX is your cut section. If you cut the portion here, this portion will get removed. Only this will remain. When you place it in the front view, when you view from the front, you could see both the thicknesses again. The portion which got cutted need to be hatched. If this got cutted, it need to be hatched something like this. 45 degrees inclination with an offset distance of similarly 45 in a negative side. This is how you need to represent hatching. Okay, when you cut the rivet from top to bottom, rivet is also cutted, but rivets, studs, bolts, screws, nuts, threads will never get hatched. Okay, but only thing is we could see those extreme ends. Before cut section, the whole diameter is invisible. After cut section, this is completely visible. Make it dark. Okay, now it is invisible. To make this visible, or if you cut the model, it will become invisible. Sorry, visible. Okay, I'll repeat here also. I'll try to make a cut section here. Okay, if it cutted, this portion will get removed. Only this will remain. These two halves of the sheet will remain. So if those two will remain, what would be the hatching part? So this is different metal, this is different metal. Why we do hatching? When you cut, we do hatching, and to differentiate the materials also we do hatching. So this is different material. I'll do hatching with 45 degrees inclination with an offset of 2 mm. Similarly, in this case also, I'll try to do hatching with negative 45 degrees, okay, with an offset of 2 mm. I'll follow. Okay. Now once it got cutted from top to bottom, the rivet is invisible inside. So make it dark. Invisible become visible now. Okay, but you are not supposed to hatch this portion. Okay, what we are not supposed to hatch after sectioning also. Note. Okay, for example, sectioning of nuts, bolts, studs, okay, threads, rivets, etc. Fasteners we can call it as. Sorry, fasteners should not be hatched. Okay, so this is about Rivets 2 lecture, how to represent all the views with given specifications on a drawing sheet. I hope you understand. If you have anything to ask, you can comment and you can subscribe. Thank you.